So we're back with the one and only Vincent Schwenk.
Hello, everyone.
Picking up or continuing from where we left last time. And due to certain circumstances, we today decided to do something rather easy-ish, and which picks up on a project we worked together on, which a part of it was simulating some object being dragged through sand, I think it was.
It was unreleased, unfinished. It got stuck on my hard drive, but the file was really looking amazing, and we should actually finish at least this one shot to make it to rendering.
Yeah.
But now I can recreate it, so that's
right. So I'll teach you what I did, and you'll see that most of it isn't too bad, and some of it is painful.
Okay. Then let's focus on the easy stuff.
Okay, so what we're going to do is set up just a slight thin sliver of sand through which we'll drag an object, and the sand will just clump, form, go away. Reiterating what we did in the last two sessions, you typically want to set this up in a geo node again.
New geo, let's get started. Geometry, bam.
Right. Excuse me.
And
right. So first thing we need is a source for our sand.
I would say let's go with the torus, perhaps.
Excuse me?
Gesundheit.
That out. Yeah, water.
And tea.
All right. As a source for the sand, a torus would work, but it would give you a circular area of sand through which you drag something through. It depends what you want. If you want
let's go even more simple with the box.
Right. If you want the whole floor to be sand, I'd suggest using a box.
Let's box it.
Again, we said Houdini was unitless, but it's assumed that 1 unit equals 1 meter. So you make up your mind how big your field of sand should
scale this down. I mean, sand is tiny, so.
Yes, but I think back then we dragged furniture through the sand. So, I mean, it doesn't have to be that high, but you want to make it wide and deep, maybe.
Something like that, perhaps.
Yeah, we can try it and move it up a bit. So now it intersects your ground plane, and you want to have the sand set above that.
Okay, I double-clicked on the object. Is Houdini re-centering the camera when you double-click on stuff?
Apparently, I never did that.
Ah, look, that's what's happening.
Yeah, space and age.
Space and age. Okay, so let's select Johnny here and let's move it up.
Yep, could do that. And now you want to create sand, and sand in Houdini and Vellum is called grains.
Don't we need a plane first?
You mean for a ground plane?
Yeah.
If we want to stick to a perfectly flat plane, no, the Vellum solver has that as a built-in feature.
Ah, perfect. So let's do that and go for grain. Mm-hmm. Grain source? No.
Rather use the Vellum grain, the Vellum configure
grain. Configure grain.
Mm-hmm. And again, this is the same as all dynamic objects in Vellum. A cloth you would set up with a configure cloth constraint. In this case, you'd configure your grain constraint, which in effect is not really a constraint, but just telling Houdini to generate points and then use those as particles, as grains in Vellum.
Yeah. So we got that. Then let's connect the guy to the left or not.
Yeah, good idea. As a source, and then set the view flag on the Vellum constraints grain. That's bypassing it. That means deactivating it.
Wait, red
flag
was
is the
also
blue thingy.
Lila, this one, the other side, blue one.
And just select the node. Just click on it. So now you can see up there in the properties that currently we do not create any points. So
wait, I see you and me in the properties. There's the recording video.
To the sides then.
Yeah. So yeah.
So right, in here what we want to do is fill this whole box with points, which is done by checking create points from volume.
Which box we want to fill? The box we created with particles.
Yes.
Why do we want to do that?
Because we need sand, and
But shouldn't the sand be on the floor and the box should collide through the sand?
No, what we're just currently doing is just placing a box filled with sand and just letting it drop on the floor first.
Okay. I thought the box is the collider box, which is driving through the sand.
No, we first need to create a volume of sand.
Okay. So filling the guy with create points from volume.
Yep. And now you see very coarse sand.
That's enough for me. That's what cinema can do.
Okay, now you've got sand grains which are 1 centimeter in diameter.
Yeah. As my experience in X-Particles and stuff, I would be already like, wow, we are pretty high res.
Middle mouse click on this node. You can see how many points you have. Just hold the middle mouse button or click on the eye symbol. So 76,000 points. That's not really much.
That's a lot.
Well, depending on your experience, I guess.
You really want to go lower? Okay.
Okay, that's better. A few things which I'm noticing here. First, you're piling up your sand really high, and you might not need it that high. You could get away with it.
I thought it's the box who's colliding through the sand. That's why I made it so high. Let's drop it down much.
Makes sense. And then you see that those sand particles are now spaced apart really evenly.
Yeah.
In this grid structure. And let's break that up a bit, which you can do on the constraints grain by checking jitter scale.
Jitter scale?
There is the box before jitter scale, where you can jitter around those individual particles.
Jitter, here on the left, jitter scale.
And don't do anything, it just takes a while. It's a bit of a slow operation.
Oh, yeah. Nice.
You can see you've got this more organically filled.
And I already like it. Let's finish.
Yeah, okay. Then let's drop a Vellum solver after that.
Vellum solver. The first one, or do we need a specific one?
There's only one.
Okay. No, wait. Is there only one solver?
There's only one.
Muscle solver, skin solver. Yeah, tissue solver. Vellum. Yeah.
Okay, the other ones are the same node, just set up differently. And if you hit, if you press J and keep it pressed, and then just draw from the constraints to the Vellum solver, you can wire up all 3 slots in sync.
Oh yeah, with the
Just you don't have to draw it multiple times, just once, and then
it
wires up all. Okay, view flag on the Vellum solver, so we can see what's happening here. And I mean, you could hit play now to see what's happening, but
let's see what's happening.
Definitely not set up properly.
Nice. Goodbye.
Goodbye, because we don't have a ground plane, which you can check there by enabling the ground position.
Enabling ground position. Ground position.
Mm-hmm.
Got it.
Now you see this blue grid there, indicating where your ground plane is. So if you hit play now, it collides, but it's going very wild, let's call it that.
It's a bit too kind of liquidy.
Yeah, it's spreading apart very dynamically, let's put it that way. So to remedy this, just go back to frame 1. The thing with grains in Vellum is they need substeps. So anything you do with grains, be it this more sand-like simulation or a liquid, needs a rather high meaning 5 to 10 substeps, and can make do with very low constraint iterations, meaning 4 to 12 constraint iterations.
Constraint low 12. How much? 12?
I would go with 5 here as well. I'm usually a fan of setting substeps and constraint iterations if I don't have any special constraint on them for the same number.
It's a constraint iteration. If we go with a lower value, is it calculating faster?
Yeah.
Good. It's not that
bad.
Now
you can see that's piling up better and settling. If we got jittery particles that don't settle, we might need to increase the substeps, but so far from what I can see here, that is looking good.
It's looking good, yeah.
Okay. So let's set up a collider, something we want to drag through there.
So collider, now we need another box.
If you want to drag a box through it, let's use a box.
Let's make this one tiny. And connect the box to the collision.
And yeah, reset it to the first frame.
And make it visible. But it's also like not very good positioned.
Right, it's smack in the center of where the particles will be.
How can I position it exactly on the ground plane?
Well, if it's the size of 0.1, you have to move it up 0.05 units.
Oh, yeah, perfect.
However, I would not do that.
Okay.
I mean, for animation, yes. But as a collider, I would actually use a collider that slightly penetrates through the ground plane. So you don't have...
But I want animation. The cube should move through the sand, like...
Yeah, but I would slightly have the cube slightly intersect the ground plane.
Okay, so 0.0...
Something like
4.5?
4.9 is enough, just so that we don't have any rounding errors that get this thing through. Okay, for animation, I assume you want to keyframe this?
Yeah.
So you move it to its start position where you want it to be at the start.
Oh. Would be good to see how far our actual other box is. I like this. Okay, we can move it a bit closer.
And with the purple flag, you can ghost that and see that as well.
Oh, yeah. Okay, perfect. And let's make a keyframe on... How do you make keyframes?
Control clicking into the field or onto the name that you want to keyframe.
Control clicking onto the word center, or...
Depends if you want to keyframe all three of the coordinates or if you only want to keyframe one or two coordinates, you just click into the coordinate fields.
Oh, yeah. Was that a keyframe?
It's a keyframe, but
nice.
I mean, you most likely don't want to animate this on the Y position, but rather on the X and Z position.
X and Z, that's true. Wait, which position? I'm always at I need X.
Down there in the lower left corner, you have the axis field. So you
on
the X-axis now. Okay, that's your first keyframe. Then you move the timeline to where you want to set the second keyframe.
Let's say, I don't know, 100 frames, perhaps.
Whatever you like. And then you move it
Whatever.
Again, control click in there. And if you shift click in there, you can open up your curve editor and see the animation curve you just created. And that was this interpolation.
Let's overshoot it a bit.
Okay.
And make it really go. Okay.
Yeah, so if you hit play now, you can see.
Let's see, is the... Oh, yeah. It's all right.
Okay. So all you have to do now is set the view flag on your Vellum solver and let that simulation run. One thing before we let that run, maybe on the solver itself. Yeah, okay. It's fine. It's not
on the solver itself, yeah.
Under the simulation tab, you might want to increase your cache to not 5 GB, but depending on how much RAM you have, 25 GB, 45 GB, 65 GB, whatever.
Okay, whatever.
Yeah, right.
What is happening if the cache is full? He writes the cache on the hard drive.
No, deletes the first frames that are cached. That's why if your cache memory is too low, you can see this blue bar in your timeline wandering sometimes in longer or more complex situations, which is what you don't want.
But it's still like very fast.
Yeah. We've got very little points here, very little.
Very little. I tried to learn X particles, but I never liked it. And because I was always watching the tutorials and they use we are using bigger particles, so the tutorial is not that slow. And I, of course, wanted to go high, and then it never worked. Yeah. It exploded. It was like, it never worked. Incredibly slow.
We too do use lower res sims for tutorials because otherwise you're just waiting forever for the caches. And I tend to...
Yeah, but you could edit your tutorials. Just make a cut, make a speed ramp, and then, come on, don't be so Oh, for tutorial purpose, I only make the big ones.
Yeah, but how long should I spend recording a tutorial, Vince? Some of the simulations I did for Artworks for tutorials literally ran overnight.
Then do that overnight.
All right, so that thing is dragging through your grains here.
Yeah. Yeah, it's not too bad, but now I see some stuff.
What do you see?
The particles are not sandy enough. They're still too liquidy.
So one idea under the solver tab here in your Vellum solver, or maybe the forces tab, I'm not sure. Yeah, might be the forces tab.
Forces tab, which is on
the Vellum solver.
Vellum solver.
Vellum solver. And then there's a tab
here,
called
forces.
Tab. And then under friction, just increase the static threshold.
Static threshold was friction.
Yeah, something high, like 5.
5.
And let's resimulate that and see if that fixed something.
Would you work like this? Try to find a reasonable values and then increase the resolution at the end, or?
It's tricky with Vellum because some of those parameters are resolution scale dependent. So I actually would try, but I wouldn't dare relying on those values to spit out exactly what I want without having a test simulation run before.
So it's a bit of a back and forth. You go a bit higher, try to play around with some values, go a bit higher.
Absolutely.
And then the overnight thing comes when you're pretty happy with everything.
Yeah, and it might even go back to another overnight sim if something there is breaking again. Okay,
so enough of here. Some particles in the beginning were doing weird stuff.
Yeah. That is typically an artifact that you see stemming from too few substeps in your simulation.
Okay, then let's increase the substeps.
Yes.
So how much is
I would try 8 for now.
8. So there are is it 10 maximum?
No, you can overshoot most or I think any sliders in Houdini. So they are typically not limited.
Still pretty quick.
Yeah.
And the flying particles are gone. Oh, there was one. Just one here.
Maybe, I'm not sure if it's a constraint iterations. You could try increasing that to 8 as well and resimming it. And if not, you need to increase your substeps.
Which one should I increase?
Constraint iterations first. Let's increase those to 8 as well.
8.
And just try if that solves it. And if not, you just...
And before that, perhaps we could already try to increase the grain a little bit.
I mean, we're still trying to figure out you can do it, but
I'll just go with 0.1001 less 0.1. Yeah. Wait, I made a 0 too much? No.
No, that's fine. You're just on the other node.
On the wrong view thingy.
You hit stop again.
What?
You just stopped the simulation for some reason.
Why did I stop it?
I don't know. Just hit play again.
Oh. It crashed.
Yeah. Segfault. Actually, it would be a good idea to save this at some point when the simulation.
Yeah, I will do that.
I mean, it's not much what we built here, but saving often is kind of...
I mean, visually, it's already nice. I wouldn't have to go too much lower, and still it's going quite fast. But also the huge question will be, how will we render that?
Well, the answer, as always, depends. Depends where you want to render it in. That means which host software and also which rendering engine.
I will have to go with Cinema because I think it will take a while till I'm that good in Houdini or that comfortable that I can also start the rendering.
I was afraid you'd say that because rendering particles in Cinema as always has some caveats, and in Houdini
I know.
straightforward-ish, but we can try our best. I haven't prepared that part, so that's going to be exciting.
Looks good.
A few things I could think of is make the sliver even thinner. Don't know if you need it that thick to just lower your particle count.
Yeah, I don't need them to be this thick,
and
actually.
or make that sliver thinner and also decrease your particle size.
Increase or decrease?
Depends what you want. So I think I would make that sliver thinner to 0.02, yeah, and then decrease the particle size, the grain size as well, a bit to 0.003 or something.
0.003. Okay.
And middle mouse on your simulation first to see how many points we have now. Yeah, 200,000, easy.
Easy. Wow, 200,000, dude. 200,000 in cinema. Yeah, ciao.
Keep in mind you're driving basically an aircraft carrier here that's built for VFX. So
wait, I
just click on the Vellum solver.
Yeah.
We're seeing a few particles overshooting here, so you might need to increase your constraint iterations to 10. Your substeps.
Constraint iterations.
No, substeps, not the constraint iterations, the substeps.
Substeps 10.
Yeah.
Personal question. What do you do in all the waiting time for simulations?
Doom scrolling.
I mean, especially if it's quick, but not that quick, you have to wait a little, but not enough to do something
Sometimes
valuable.
I have a second instance of Houdini open where I have a second setup I'm working on. Sometimes I'm doing organizational stuff, emails, calendar, stuff like that. Sometimes at home, I have 2 computers.
That's nice as well.
Yeah, that's that.
Looks good.
Cool. We could talk a bit about clumping.
Yeah.
However, I would recommend saving this.
Yeah, the time to save. Going back into ancient history here. I go with desktop again.
You're gonna get used to it.
Grain Fun 1. Grain Fun 1. What a creative name.
Yeah, what an appropriate name. So for clumping, we're just gonna model that a few of those sand grains are being connected through something sticky, rubbery, holding it together. And we can do that by inserting a glue constraint between the grains and the Vellum solver.
The grains and the Vellum solver. Glue.
The Vellum glue, that is.
Vellum glue.
And so that just so that we see what's happening there, create a null. Set it next, to that solver.
Next.
And wire in the pink slot coming out of the Vellum glue into the null. And then set the view flag onto that null so we can see how the constraints look here. And you see currently we don't have any constraints. We just have those individual points, which are our grains. And now we want to create those individual rubber bands constraining and clumping together nearby points, which you can do by going to the Vellum glue and setting this to work not on primitives, because grains are not primitives. Primitives are polygons, basically. Primitives are lines, triangles, quadrangles. We want this to work on points instead, which are particles. And also on the target geometry, we want the targets to also be the points. So if you scroll down, we want that to be points as well.
Oh, now something happened.
Now you see some individual connections appearing there and your viewport getting slower because now we have to draw lots of lines, which is heavier on OpenGL than just...
It is really getting slow.
Points. Yep, that's the beauty of OpenGL. So we now have individual points that are nearby, just connected one by one with a single line. However, we might want to have a few more than just 2 nearby points connected. So if you scroll down further under glue search here, you can select how to search and which nearby points to connect for. And in this case, just increase the constraint points to, I don't know, 3, 4, 5, 6. And after a bit of waiting, we should see much more points being connected there. Yes. Takes a bit to update here on my side, I think.
Oh yeah, I think I didn't see an update yet.
That is weird because it's stopped calculating.
Oh, or did it update? No, there's a watch. Oh, we crashed it.
No. We did not. If it would be working, in the lower left-hand corner of the program, you would see some status bar telling you that it's doing something. Just set the constraints per point back to 1. It's doing something.
It did change it, actually.
Definitely. So set it back to 5. And then let's scroll down to the actual settings of those individual rubber bands connecting those points now. So first we have the stretch and the compression stiffness, which for this case I like to set at the same value. And I tried to prepare this or tried to work this through before we go here. And in my examples, I ended up with a stiffness and a compression stiffness of 100 or 50.
50.
So wait. So these sliders, how they work is first with a multiplier and then with a tenor multiplier. So now what you did here in the stiffness is you dialed in the value of 500, right?
Okay. And here is it 1,000 times.
Yeah, so I would suggest setting both to 100 and doing that by not adjusting the stiffness values and just leaving them as 1 there instead of typing in 5 there. And just setting the postfix to 100. That thing, right. And then those rubber bands will always be there and always try to pull back individual points, which looks kind of awkward when you move the collider through it because the sand will go back. So actually what we want to do is if we have a certain amount of stress, of stretch, we want those constraints to break, which is what the breaking tab does here. And the threshold is, it depends on your stiffness, at least when you set it to stretch stress, because the stretching stress is dependent on your stiffness and how far those individual rubber bands have been stretched. In my attempt, something between 0.2 and 0.5 worked. Let's try 0.3 for now, maybe. Right. Now, wire the null into the pink output slot of the solver so we can see what's happening in the simulation with those constraints. Nope.
What, where?
The output of the solver goes into the input of the null. Hit escape. Hit escape.
Escape, yeah. The output of the solver goes into the...
Right. So we can see what's happening to those constraints as they are being simulated now if you run the simulation.
What do you see there?
The individual connections, the individual springs connecting or rubber bands connecting the points that make up the grains.
Okay, some really wide dense mesh. Something's
Doesn't
happening
matter.
here.
Just look at the whole simulation, how it works, and I'll talk a bit about what I'm looking out for and how to diagnose this. So just let it run. As soon as a point is disconnected from all its springs, it becomes very visible in the matter that it turns black and isn't part of any line that is white. And you can see those individual black points here. So those are points which are not connected. So what I'm expecting now, if our breaking threshold is dialed in correctly, is that around the areas where our collider goes through, we are seeing more black points as they are being disconnected because we have a higher stretch stress there.
Yeah, it looks already nice. Just like that. Which is already
happening, and we are not getting that effect where the straight where this thing goes through is closing again because the constraints have been cut behind it.
Looks nice.
So yeah, you can also set the view flag on the Vellum solver now to see how the whole simulation looks with the grains and not with your constraints, and see if that's something you like, something you expect. So a few parameters you could dial in here. First, the stretch, the breaking stress. So how easily those individual rubber bands get cut, depending on the stretch they feel. But also when you go into the Vellum glue constraints, and maybe before I stop the simulation, so the whole thing responds a bit quicker. Yeah, if you go up to the neighboring search,
up to the neighboring...
The glue search.
Glue search, yeah.
So there you can dial in how many individual constraints a point can have at maximum, so how many potential points around its vicinity it could connect to. That also dials in how the look is, as well as the detached point chance. So that means how likely is a constraint to be actually created. So say, for example, you tell a point you can have maximum of 10 constraints around 2 points surrounding this. And you have a detached chance of 0.5. In reality, only 5 random out of those 10 connections will be created. If you have a detached chance of 0.8, only 2 out of those 10 constraints will be created.
Okay. Should we do that?
Yeah.
Detach point. Object chance or point chance? Which one was it?
Point.
No,
it's a value between. So a chance is a percentage value between 0 and 1. So 0% and 1 being 100%. So now you've got a 50-50 chance of a constraint being actually created. So each point, instead of 5 constraints, now statistically speaking has 2.5 constraints. So some have 2, some have 3 constraints.
Yeah, nice. Okay, then run it again.
Yeah. Maybe just click on the Vellum solver so we don't see the visualization of the Vellum glue.
On the Vellum solver.
Right. So yeah, that's actually waiting for the simulation is the more painful part of this.
Yeah. But I would say this looks pretty good.
Right. Then let's export it.
Yeah. Should we first... Oh, my camera's overheated.
Camera overheated.
Yeah, that's weird. It doesn't hold very long, actually.
Did you set it to 4K?
I don't know.
Maybe.
Might be.
It does that in 4K.
Probably it's still set up in 4K.
Yeah, it's those beautiful Sonys. I've got that as well. Mine overheats in 4K as well. Reliably.
So then let's wrap this up.
By exporting this. So, middle mouse on the Vellum solver to just see how many attributes and which kind of attributes we have on our geometry in here. And you see we have a lot, 28 point attributes, primitive attributes, detail attributes. And realistically, you might only need velocity maybe for motion blur and maybe a p-scale. And I'm not even sure if Cinema 4D is able to import that. So let's use an attribute delete and wire in the first slot of our solver.
What is attribute delete?
Yeah, just type @del. Nope, 2 T's.
What?
2 T's. Attribute. Yeah, there we go. And wire in the first output slot of the solver into the first input slot. All right, so camera is working again. We still got the simulation. We stopped at trying to get rid of some of those attributes we don't want to export. So first output slot of our Vellum solver goes into the first input solver of our attribute delete. And in the attribute delete, we want to basically delete anything. That's done by selecting the asterisk. So
asterisk? What's asterisk again?
Typing the star, the multiplication symbol on your keyboard.
This is called asterisk. Asterisk.
Asterisk in English, in German and French, I guess it's called Asterix.
Asterix.
Or a star.
Perfect. Everyone gets an asterisk.
Yeah, everyone gets an asterisk for now. However, now we're deleting everything. And there are some attributes we want to keep on the points. So for example, the velocity. And we can do that by typing in a space and then excluding the velocity from the deletion by typing that hat symbol, which you might remember from the previous sessions we did.
Hat. Where was the hat again? Wait here. Ah, damn it. I'm opening my password manager.
And then small v for velocity. And also let's maybe export the p-scale. So exclude that in the same manner. Space, then the hat symbol, and then p-scale. Yep, like that. So now if you middle mouse on the attribute delete, you should see only those two. No, on the attribute delete node itself. Yes. Now we only have 2 groups left there, which we also don't really need. So let's delete them as well using a group delete.
What 2 groups? Where do you see what?
So first I'm seeing a number of points here.
Yeah.
0 primitives, 0 vertices, and then just those unconnected points. And then I'm seeing my 3 point attributes, which I still have, the position, the velocity, and the p-scale. And then I see a point group and a primitive group. The point group is called stream default source, and the prim group is called Vellum object 1.
Yeah.
And we don't really need them. They will only, if at all, blow up our Alembic. Groups are not really attributes, so you need a separate node to delete them using the group delete. Correct. And in the group delete, you can just delete any groups again by just typing in an asterisk.
Group name.
Correct. And if you middle mouse on
Or delete unused groups, it's the same? No.
No. Just click somewhere to make that node execute. And up there, oh, okay, no, that's the null, that's the white, that's fine. Middle mouse on the group delete to see if that worked. And yes, now we don't have any groups. And we can use an Alembic ROP to output this to Alembic. Then here we're outputting the frame range, frame 1 through 160.
I think we should make a little bit less, otherwise we wait too long, right?
Sure.
Let's make it 120.
And now you're writing this out to your desktop, and it's called grainfun01.alembic.
Grainfun01 is a perfect title for the tutorial.
Yeah, and that should be good. So if you hit save to disk, that is going to export.
So tell me something about you.
What do you like to do in your spare time?
I was just cycling.
I was cycling yesterday. I'm going to go cycling tomorrow.
Perfect. That's why I'm so thirsty.
Yeah, the relaxation days, the recovery days in cycling are the ones where you just eat your whole fridge, basically.
Exactly. Talking of that, I still need to go shopping, grocery. My fridge is empty.
When do the stores close in Hamburg?
The last one at 12.
Okay, easy. It's not like in
the
Bavaria where they close at 8.
Bio company close at 9.
Okay.
Yeah, Bavaria. München, ciao.
Yeah, nothing after 8.
No kiosk at all. And everything closes at 8.
Well, there's 1 or 2 kiosks, and you've got 2 chances, basically. One is your supermarket in the main station, and the other one, if it's really urgent and really bad, it's the supermarket in the airport. But you're gonna be
congratulations.
But you're gonna be
also for everyone who don't know Munich. Well, actually, I'm from there. That's why I also know the city. But going to the airport will take you at least 45 minutes plus.
Yeah, more likely an hour.
It's 17 euros just to go one way with the.
Is it 17 by now? I thought it was still 14 or 15, but yeah.
I don't know, something, but it's incredibly expensive. Yeah. So it has to be very important.
Okay. Munich tips left aside, I think you can fire up your Cinema 4D to see if this properly imports.
Cinema 4D is coming. Who is faster?
Close.
So let's delete some stuff here, and
your default scene gives you the same habit as a Blender artist, just starting a software and starting by deleting something.
I often use it as, I don't know, something, but yeah, it's good.
So I think we saved this onto the desktop.
Yes. Come on, it's always snap. What? Okay. I tried to move it because, again, our faces are in the way. So desktop, Alembic. Is still writing?
No, I don't think so.
No preview available.
I think the scale is too small here, so you want to scale it.
Was it 100?
Yep.
And
we are
we-
importing points as particle geometry. I'm not sure what's the default, what the default workflow there is in Cinema 4D. Let's try the particle geometry.
Yeah, and did we work in 30 frames? In 24 frames?
Let's check. I think
Wait, we changed it last time
to 25. So let's just check. Lower left-hand corner, that weird icon.
Lower left, weird icon. They're all weird.
That next to the speaker.
Yeah.
Side, next to the speaker on the left.
Next to the speaker.
25 FPS, yes.
So 25, okay.
And that looks like particle geometry. Nice.
That's something. Let's see if something's happening. Looks good.
Yep.
But the cube is kind of...
No, we didn't export the cube.
We didn't export the cube.
No.
But we also need the cube.
Okay. Then let's export this as a separate Alembic.
So another Alembic guy. Wait.
And you just wire the cube straight into that other Alembic ROP. No, that's your source for the grains.
Yeah, the wrong one here. This
and you write that out. Save the disk.
And
maybe give it another name. So you're not overriding the other thing. So now you're calling it I don't know, $hipname _ cube. Yep. And now save this to disk. And that should be really fast. So
it did already do it, right?
Yeah, I think so. So if you import that as well. Okay, that didn't work with the cube. We just called it .abc, so whatever. But 100 centimeters, and there's your cube.
Nice. Let's see if something's happening if I switch over to Redshift.
I am not sure how the thinking particles versus Redshift integration is done in Cinema 4D. And
me neither.
To render that.
So let's see.
So of course nothing happens. I would assume that in Cinema, Redshift settings are done by a Redshift tag.
Yeah, I also think this is quite easy. Redshift tag, and then we particles here.
Yeah, particles.
You need to throw something in there. Or no, we can use optimized spheres and
yeah, maybe that's
bam.
Yeah, well,
here we
you
go.
Just have to dial in the scale accordingly. And I think it's 0.003 is what we set up. No, 0.003. So another
more 0.
Okay, that isn't
too
it.
Small.
So maybe it's radius versus diameter. So let's try 0.006. Maybe it's the diameter.
Yeah, still too small.
I'm wondering if the p-scale attribute comes over. So 0.001, that might make sense.
But it's still too small, I think. Looks like there's too much hovering going on.
Yeah. Yeah, so I'm absolutely maybe 0.15 or 142. Yeah, something like that.
Yeah.
I'm a bit out of my waters here in how Cinema 4D handles particle rendering.
That's all right. I can play around with Cinema later on and try to find something there. But it's looking not too bad, actually.
That's how I set this up. I think the trick here is for quicker simulation times, for quick-ish simulation times, is to only simulate the area in which you're dragging the colliders through your sand and just adding kind of static sand onto the other areas if you want to have a wider area filled with sand.
Yeah. I mean, we can do this in the next one if we will update the scene and work a little bit on design and art direction.
Sure.
Because, I mean, this is kind of boring, but I'm already like, this looks pretty nice.
Yeah, I mean, it's the basic setup. So it's just slamming together a few grains, clumping a bit of them together with glue constraints, and then making sure the simulation doesn't totally break by adjusting substeps and constraint iterations accordingly.
And also I could play around a little bit and see how to work with the particle settings and if you could find something interesting. And is there like a value for a random particle color? So, or I don't know, or can we export the values to be able to get random particle colors?
You can definitely export them. Again, the question is if Cinema is able to import them and handle that.
Let's see if Redshift itself has something. They have some particle thing here, didn't they? No, they don't. Or did they have?
Do they have a random something node?
Redshift material. There's a particle material.
Okay.
I also kind of never used it before. So color user data, but we don't have any color user data.
Currently we don't. So again, I don't know how Cinema 4D handles this data import. The last time I tried it was like 5 or 6 years ago, and you had to set up a few nodes in thinking particles to actually read in the attributes. I'm not sure if they still require that, which back then was, I mean, it was doable, but it was an annoying thing to do.
Yeah.
And I'm not sure how and if that changed, but I can show you how to set up a random color in Houdini and export that.
Also, I have an idea. We could just throw in different objects in here. So we have a bit of variation in the sand itself.
Sure.
I mean, not now. I will play around a bit and see how it goes, and we can make it cool in the next one.
Want me to show how to export random colors onto those, or shall we do that in the
Yeah, let's also do this as a last step for today. And
okay. So before you export the particles, just add an attrib noise, maybe. Not necessarily a randomized, but an attrib noise. There you go. And just wire that in there.
Before the deleting.
No, just, before the raw Alembic out, right there. And set the view flag on it, and that should already be it. Yeah. So it's now using a noise to drive CD, which is the color diffuse, which is the color of the individual points. And if you scroll down, you can set up all kinds of noise settings in here. For example, the element size is basically the scale of the overall noise. Yada, yada.
That is better, so we can adjust the particles better than... Let's see if this is doing something. Should we export it again?
Try it. It will export. You don't have to shorten it. It's already pre-cached, so it'll export.
Oh, but that's nice.
Yeah, everything that's blue is already cached and will export in a heartbeat.
Export, and with the last time it didn't work with the dollar hip
just
name.
delete the dollar hip name and just give it a name you want to give it.
Colors.
Yep, and there's exported.
That's pretty nice that you can export it so quickly when you change
It
something.
depends. Everything after the simulation that you change does not affect the caching, so that usually goes pretty quickly. Okay, I wasn't sure if we needed to check some settings there by importing it.
Let's see again. Colors.
So, optional data, color maps comes with it. Okay, so yeah.
So the color user data has RSP color. TP.
Yeah, use the CD vector. Use that one.
Nice.
There you have it. Really easy. That's nice.
Why
you don't have to,
vector is a color, a vector?
Sure. A vector is just a list of values. That's what a vector is. So a vector can have 2 elements. For example, UV coordinates are a vector. A vector can have 3 elements, such as a position, a direction, a velocity, or a color. With red being the first, green being the second, and blue being the third element. It can have 4 elements to encode orientation using a quaternion. And in data science, it can just have as many values as you want to.
Nice. So, yeah, that's good. I mean, with the color, I can definitely work better to make the sand a bit more unique.
Yeah.
Noisy.
I think tweaking and everything else we're going to talk about in the next one, right?
Yeah.
Good.
But also, it's good for me to play a bit around before we have the next recording session, so I know a bit better what's happening there.
Yeah, sure.
Great. Thanks,
All
Mo,
right.
for this
Pleasure,
next
Vince.
lesson.
See you next time. Cheerio.
Have a good one. Bye-bye.